Hi everyone, in this video we're going to be looking at the different types of chemical bonding. So let's start with ionic bonding. Ionic bonding is the type of electrostatic attraction between a metal ion and a non-metal ion. The metal ion is always going to be the positively charged cation, and the non-metal ion is always going to be the negatively charged anion. And the reason for this comes down to electronegativity. Non-metals are generally more electronegative than metals, and they're going to be able to gain an electron, so to completely take the electron from the valence electron shell of any type of metal. Okay, so if we look at our quintessential example of sodium chloride, we've got the sodium, which has one electron in its outer energy level, and that is going to be transferred to chlorine's valence energy level. Okay, and that is going to result in a positively charged sodium ion and a negatively charged chloride ion. And what is going to form is a lattice structure. So it's not going to be just one sodium and one chloride ion. Okay, this is going to be a lattice structure, three-dimensional structure where we have a positively charged, if it's a 1-to-1 ratio like sodium chloride, where we have one positively charged ion surrounded by, we're going to have 1, 2, 3, 4, and then one in front and one behind of the negatively charged ions. So it's going to take on a regular, uniform pattern. Okay, and so what is keeping these ions together is, once again, the electrostatic attraction between the negatively charged, or between the oppositely charged ions. Okay, so that's a little bit of the breakdown of what an ionic bond is. Now, covalent molecules. Okay, covalent molecules, the way that we can start to figure out what substances are going to form covalent molecules are going to generally be when we have non-metals form molecules. Because non-metals, generally speaking, have closer electronegativities than, say, a non-metal and a metal, they're not going to be able to pull electrons completely away from one another, coming back down to electronegativity. So they're going to end up sharing molecules, okay, between the nuclei of their atoms. They're going to end up sharing electrons between the nuclei of their the nuclei of the atoms in the molecule. Sorry about that. And we'll have, as we know, two types of covalent molecules, some which are polar, okay, so some which have areas of negatively charged and positively charged dipoles, and some which are non-polar, so there's no area of overall charge. And so examples of that would include water, which has our oxygen, which is electronegative, and the hydrogens that are electropositive, and a non-polar, which would be generally any substance that contains a carbon and hydrogen bond. So one like methane would be a really good example of that. And covalent molecules, so when we're talking about that, you'll notice that all of these atoms are non-metals. Okay, so what is the difference then between a covalent molecule and a covalent network? Covalent network also comprises of non-metals. However, they're going to form lattice structures. And there's just a couple of examples that we need to be aware of. So one of our examples is diamond. Well, we've got actually two allotropes of carbon, so two different types of structures of the same type of atom. And we've got graphite. And they're going to be made up of not just a set or designated number of atoms, like in methane and water. Okay, a molecule of water is always going to contain 2 hydrogens and 1 oxygen. A molecule of methane is always going to contain 1 carbon and 4 hydrogens. Whereas diamond is a carbon atoms which have the tetrahedral structure of all four bonds with carbons on all sides of those bonds. Okay, so, and that is just going to be extensive. That's going to continue extending out and out and out. Okay, and so it's an indefinite number of carbon atoms. Likewise, graphite, okay, which is a little bit different, it's going to have 3 bonds between other carbon atoms, and it's also going to have one kind of lone pair of electrons that floats between this lattice structure. Okay, we're not going to go into too much detail about graphite because I've covered that in another area about allotropes. So essentially, that is the difference between molecules and covalent networks. This is, we're not going to have a specific number of carbon atoms within these structures, okay? But you can safely assume that there are going to be a great many number, okay? And also back to when we talked about lattice structure in ionic, it's a regular repeating pattern. Okay, and so that's what a covalent network is. Okay, the electrons are still shared between these carbon atoms, but it's the general overall structure that is different to when we talk about discrete molecules. Last but not least, metallic bonding is going to occur between metals or occur within metals. And so how do metals exist? Okay, perhaps in junior school we thought, okay, well, metals, they exist as atoms. Okay, so we've got one magnesium atom directly next to another magnesium atom, so on and so forth. And this is how a piece of magnesium would exist. But we actually get down to the the atomic level in senior chemistry, where we start to understand that actually no, the metals is another, well, metallic bonding is another type of bonding which results in a lattice structure. Okay, and how does that occur? Well, we have actually not the atom itself, but we have the metal ions, okay, that are in formation in a regular repeating pattern here. So I'm just drawing a few more examples of the magnesium 2+ ion. Okay, it's in group 2. It's going to have both of those 2 valence shell electrons be located within the lattice structure. And so what happens to those electrons, okay, from each ion? They are going to be freely floating, okay, within the lattice structure. They are going to be mobile, and in some instances we call that delocalized electrons, because they're not actually attached to any one given ion. Okay, so this electron moves over here, this electron moves over here. Overall, we've still got no overall charge, so we don't have a charge on magnesium if we were to write it, okay, in its elemental form. But what we do know is that these electrons are able to move through the lattice structure of ions, okay, and that's going to give metals properties like its high electrical conductivity. Okay, so that was a little bit of a summary of the types of bonding. I hope that has helped you in understanding further in chemistry. Okay.